Fran Lab. What are my thoughts on the 3I Atlas or 31 Atlas? I always say it's 31 Atlas because every time it's printed it's 31 Atlas, and they said no, it's 3I Atlas. Well, that's a 1. Well, no, it's a capital I. Well, capital I, the font should have, a serif on it for it to be an I. If it's just a slash, it's a 1. So it's like the compact typewriter. There is no 1 in the numbers. You got to use an L, lowercase l for 1. What do I think about it? It's a big space rock. One thing that the new Sky Survey, as the years go on, is I think we're going to find that these really rapid interstellar objects are a lot more common than we realize. The only reason that we've even found these really fast objects in the last few years is because we've got so much going on as far as deep space observation, and especially real time and wide field with computer software that can actually look at millions of dots and determine which ones are moving and how fast they're moving. And it's really just because of our detection tools that we've even found these recent objects. I think that as we gather data over years, decades, with these bigger telescopes, I think we're going to find these things are coming through the solar system all the time. And it makes sense because, there are obviously cataclysmic events, exploding stars, colliding black holes. There are events in the galaxy and even in other galaxies and outside the galaxy and clusters and such that are so profoundly energetic that it absolutely makes sense that we would have very, very fast moving chunks of debris, very large ones and very small ones, that are going to be hurtling through the galaxy. And it only makes sense that if they're whizzing by our solar system, that a lot of them are going to get pulled in to the gravity well of our star. And so, even if we find an object that has a trajectory that shows that it's not coming from the galactic plane, that doesn't mean anything, because it's a false perception to think that all of the stars in the galaxy are in the galactic plane. There's a lot outside the galactic plane. We've got globular clusters, we've got random stars, we've got objects that are outside of the galactic plane that are part of the galaxy, but they're not in the plane. They're above and beyond and outside in these sort of, clouds and blobs, and a lot of that stuff is left over from the last galactic collision, because as we found out in recent years from more detailed observations of the stars in the galaxy, that our galaxy, the Milky Way, is a barred galaxy. It's got a bar through the center, and that bar in the center of our galaxy is itself a remnant of a galactic intersection, a collision that happened, billions of years ago. So if you imagine, we got this barred galaxy, and in fact our galaxy probably got to be as big as it is because two medium-sized galaxies collided. And when that happens, if you've seen computer simulations of average spiral galaxies colliding, well, first thing that happens is both of those galaxies, they become obliterated. They just become a massive just jumble of stars. And over millions of years, those stars begin to coalesce into a new spiral with some remnants. That's what the bar in the middle of our galaxy is. But part of the remnant of that kind of collision is that not all the stars end up back into a nice even plane. You end up with globs of stars that remain kind of satellites outside of the galaxy or just above, and just random stars and star systems that don't make it back into the galactic plane. They kind of stay above and everything. And those stars are gonna go supernova and they're gonna conk into each other and everything. So yeah, it's not unusual to have a rock coming from basically any direction. And honestly, let's be real, it could be older than the galaxy. It could predate the galaxy. It could be an intergalactic object coming from intergalactic space, from an event that happened, 10 or 12 billion years ago, something that's older than the stars in our galaxy. So, yeah, there are so many possibilities, but we're not going to know anything. This is the bottom line. We're not going to know anything about interstellar objects until we can get a chance to intercept one. And that is what everybody in the scientific community is talking about. We got to get a spacecraft ready. We have to be prepared to intercept one of these objects. We have to have a spacecraft at the ready, either get it into an orbit, or get it into a Lagrange point and park it there, but put like a big rocket motor on it that's just making it at the ready to get going really fast in any direction, but get it out there and get it ready, and then be on the lookout for one of these objects. And when the right one comes through at the right trajectory where we would have a possibility of intercepting it, then we just go for it and we intercept one of these rocks, and we get up close and we put a lander on it, just like we've been doing with asteroids in recent years. But that's really what we have to do. We have to have a mission specifically to get up there and wait for one of these like high-speed objects, these interstellar objects. Then we got to go and intercept it, put a lander on it, and maybe the ultimate thing would be to get a piece of one, to get a lander on there that could get a chunk of it and retrieve it and bring it back to Earth, and we can examine one of these rocks. And maybe if we did all that, intercept one, get a chunk of it, bring it back for examination, and we could look at the geology, the metallurgy of the actual material in it, we could get an idea of how old it is, maybe where it came from, maybe what created it. But yeah, I think these high-speed interstellar objects, I think we're going to find that they are very common. In the lab. That's where I work. In the lab. Go berserk. In my lab. That's where I work.